Hello, this is my simple VR variant video. In this video, we are going to be making a VR game as opposed to a VR experience, and this is aimed at about an hour-long workshop. It's not too complex. What we're going to be building is a simple scene here where we have some sheep, and we're going to attempt to drive the sheep into the shear-o-matic, and I'm going to go ahead and restart this because once they get stuck in the corner there, it's just kind of a pain to dislodge them. So there we go. And then when we get all the sheep, it just says game over, like that. So, okay. And so we will be following along with our learning cycles here. We're going to be doing these 8 learning cycles. So what we're going to do is we are going to start with the project. So from this project, there's not going to be a separate project, handout project, and a final project. This is simple enough that everything is doable from within this project. So we're going to open the project. We're going to create a new scene. And I'm going to delete the directional light in this scene. And then I'm going to go to my prefabs folder, and I'm going to notice that first and foremost, the stuff that's relevant for this workshop is the only stuff you'll see in here. Everything else that we don't really care about is under this demo files, which this makes it nice and easy. People aren't seeing all this extra stuff. Only the stuff that we care about is here. So I'm going to go to my prefabs, and here's scenery. I'm just going to click and drag it into the hierarchy. I'm going to do the hierarchy so it is kind of centered on my world there. Now we're going to see the light baking and stuff kind of continuously going. We can leave that, or we can choose to sort of manually build it. It's entirely up to us as an optional step. So now that I have this in my scene, I'm going to go ahead and file save scene as, and I'll just save this in my scenes folder as main. And then I'm just going to go ahead and opt to actually just manually build this so it stops doing all that. So I just set the real-time resolution really low and hit build, and then it just goes real fast. But that's, like I said, an optional step there. And while that's finishing up, so here's the learning cycle. So we open the project, create a new scene. You'll delete the directional light in the scene, drag the scenery prefab into the scene via the hierarchy, save it as main, and then optionally manually build the lighting. Okay. So the next step is to do with navigation. So we, as the player, are going to navigate with, or are going to move via teleportation, but that's going to rely on this nav mesh to make sure we don't teleport off the side of the world or in the middle of a building or anything like that. And then the sheep are obviously also going to use navigation. So I'm going to go ahead and open up my navigation window, and very simply, I'm just going to hit bake. And that's going to bake my nav mesh. The scenery game object, the prefab that we dragged in, is already static, except for the reticule. It's the only thing that's not static. And you could use this as an opportunity to talk about the types of static, but that part is already done. Another thing worth noting is that in case anyone checks it out and asks about it, the shear-o-matic is not static. Well, it is static, but I also have besides it being static, because it doesn't have a collider on it, I have a nav mesh obstacle, which causes it to carve into the ground, because it doesn't have a collider otherwise. So, if someone notices that, just why that nav mesh obstacle is there, it's just so that it appropriately carves the ground. Alright, so real easy cycle there. What you would do is you would just open your navigation window, and you'd bake your nav mesh. Alright. So now what we're going to do is we're going to set up the player. Now, we can't really move the camera. The camera's going to be the player, but we can't really move and control the player in a VR situation because VR automatically controls the player based on positional tracking of the head and rotation of the head. So I couldn't just move the player camera around however I want. So what I'm going to do is I'm actually going to create another object. So I'm going to create an empty game object, and I'm going to name that player. And then I'm going to go ahead and take my main camera and nest it onto player so that when my main camera moves with our head, as we're looking around with a VR headset on, we can move the player parent object, and that's going to move us around the scene. And this main camera, I just want to center it on my player there. So there we go. So it's centered on the player. And then we just kind of want to move the camera back and up, find some spot that we like. Now I happen to know some coordinates that I like, but you could just keep going back and up and however you want. But I'm going to go ahead and just manually position this. So I'm going to go ahead and place this at negative 8.5, and then 37, and then negative 50. It's worth noting that the x is actually negative 8.5 and not 0 because this world, for whatever reason, is off-center. It's just how it was modeled, so a little bit different there. Also, you may have this inclination to put some like downward perspective on it. This is a really bad idea because in VR, if I'm looking parallel to the ground, straight forward, but I'm looking down in what I'm seeing, that's going to make me very uncomfortable. So we'll just leave that at 0, and we'll let the player look down if the player wants to look down. And that'll feel much more natural. Now, to simulate having a VR headset on, since we're still in the editor, I'm going to go to my scripts folder, and I'm going to go ahead and grab the camera editor control and drop it on here. We've seen this script before. It's nothing new. We're basically just, if we tell it we want to use mouse control inside the editor, we just use the mouse positions to sort of move the camera around. So that's pretty normal, and at this point I can hit play and look around as if I was wearing a VR headset. The last thing I want to do here is I'm going to add this player mover script. Just drop it right on there. And the player mover script is pretty straightforward as well. All these scripts will be commented, by the way, so you can check them out, and so can other people. The player mover script first wants to know, hey, what's the player's height? This is useful because if we just teleported to where we were looking, our head would be on the ground, and that would seem very odd. Instead, we want our head to be above the ground, as if we had a body underneath of it. So I'm assuming a height of 2.5 units here. Taller people may want this higher, shorter people lower. This could be a good opportunity to have like a, I don't know, a slider, a range indicator. Everyone can just sort of set their own height or whatever, but you know, just player height is what it is right there. Then we have these reticules and particle systems, which don't exist yet, so we'll ignore it. And this, what is ground? What is our ground layer? So that we're trying to move on the ground and not out in space or anything like that. Inside start, we just grab our start position, and then we update our reticule and we move our position. So we're going to assume that we're not looking at a valid spot, you know, so we don't teleport into the air or anything like that. And then, and this is classic, we just generate a ray from the center of our screen, pointing forward, so basically right between our eyes, right down to whatever we're looking at. And if we hit something on the ground layer, then we're going to say, okay, find the spot on the nav mesh that is closest to that. And we say within 5 units. If there is something within 5 units, or if the nav mesh is within 5 units of where the ray hits, then we have a valid spot, and if we have a reticule, we can move the reticule there. If we don't have a valid spot. In moving, all right, if we don't have a valid spot, we don't do anything, and if we press fire 1, which is touching the screen, inputs on the Gear VR, the cardboard, or whatever, then we're simply going to move the parent, remember the parent, right, because we can't move the camera itself, so we're going to move the parent to that spot on the nav mesh. And if we have a teleportation effect, we'll hit play. Now, if at any point we hit escape key or cancel, back button on the Gear VR or whatever, we're going to move back to our original position back up in the sky, just to sort of reset our viewpoint. So that was a lot of talking, but this step, you know, is pretty simple. All I have to do is say, what is ground? The ground layer. So only one thing on that layer, and that's this piece of ground right here. And that's going to get us teleporting around. So I'll try it out. I'll hit play, and I'll look. And, oops. And the problem is that I put both of these scripts here on player, and that was the wrong thing to do. So, whoops and whoops. Those are supposed to go on the camera. Player simply exists to be moved around. So, the camera is where I want to put these things, so my apologies. So camera editor control on the camera, and we saw that it worked on the player, but it's just good to keep these things together. And then the player mover also on the camera, so that when it tries to move the parent, there is one. Otherwise, you get an error. Okay, and I'll just put that on the ground layer. So now I'll go ahead and look, and I'll see when I click, I teleport. Now I jump straight forward, and that can be problematic. It's also really hard to aim, and so we're going to fix both of those things in the next step. I mean, even playing this, without a VR headset kind of makes me a little uncomfortable. But for this step here, this cycle, setting up the player, what you'll do first is you'll create an empty game object named player and nest the camera under it, right on top of it at 0, 0, 0. And then you'd move the player up and back from the scene, and I just have sort of the position that I like there. But you can do something else. It's entirely up to you. And then you're going to add the camera editor control script to the camera, And you're going to add the player mover script also to the camera and making sure you set up what is ground. All right. So now that that's done, you're going to go ahead and polish this VR a little bit. So like I said before, just jumping straight forward without any obfuscation, without any masking, right, can make people very uncomfortable. Also, it's really hard to aim without any form of reticule. So I'm going to go to my prefabs folder, and I'm going to locate this teleport effect prefab. And I'm just going to click and drag it onto the main camera. And it's a really simple particle effect, right? It just is some particles that shoot out a cone. But there's so many of them and they're so large that they mask your vision momentarily, which makes for a really neat way to teleport around. Now, I'm going to go ahead and go back to my main camera here, and it says, okay, what's my teleportation effect? I can just click and drag teleport effect onto there. And where's the reticule? And if I look at scenery, I have a reticule right here. Now, on a quick note about the reticule originally was simply just moved with your looking. You would look and the reticule would move to that spot. And that worked, but there was a jumpiness to it. If you looked really quickly, or there was a jitter in how your helmet was working, or you're moving your head in a certain way, the navigation marker, this reticule, would jitter and maybe jump quickly between spots, and it seemed very odd, and in VR it was fairly uncomfortable. So what I did instead is I have this reticule mover script, and it's a real simple script. All it does is instead of moving the reticule to a spot, it is simply going to say, and I probably should have zoomed the other scripts, it's simply going to say, okay, public void, set target, that's where I want it to go, and inside update, it just lerps there. All right, so instead of moving immediately, it's just going to lerp. All right, and that way it moves smoothly. And so now that those are set, reticule and teleport effect, if I look, I'll see the reticule moves, and again, it's smooth. Instead of just jumping around, it's lerping there, and when I teleport, the actual jumping is obfuscated or hidden by that sparkly effect, and it is not nearly as uncomfortable to do. All right, and it's also a really easy step. So for the VR polish step, you just drag the teleport effect prefab onto the camera, and then you'll set the reticule and teleport effect property of the player mover script and test it out. Alrighty. Moving on. Now it's time to add some friends. We have some sheep. So what we want to do is we're going to go to the prefabs folder, and I'm going to go ahead and locate some sheep. Now, I'm going to work with the normal sheep and Elvis sheep, and I'll just add a couple here. So a couple normal sheep. I want to be careful how many I add. Too many sheep and their nav mesh agents are just going to push each other into each other, and it gets kind of clustery. So I just, a couple. They're just enough to get the impression of the game. And on these sheep, one of the things that's kind of neat about them is they have this alpha sheep. Sheep want to herd together, so they'll try to stay close to their alpha. I could make one of these sheep the alpha, or otherwise we have this thing called the Elvis sheep, which is just another sheep, but it's automatically set to alpha. You generally want one to have alpha, that way the sheep just naturally sort of herd together. And so by dragging the sheep into the scene here, now if I hit play and I look, and I can see that they're just sort of kind of mosey around and try to sort of stick together. If one gets too far away, it'll run over there, and you can get real close. And you remember, this is where the height comes in. If I had made my height a little lower, I'd be more eye level with the sheep, and you can just sort of take a look at them there. All right. So again, another easy step. So we're going to add some friends. We'll locate the sheep prefabs, drag several sheep into the scene, and we'll set one sheep as the alpha. All right. So the next thing is we want to be able to herd these sheep. We want to be able to push them around. All right. So right now we're just sort of teleporting, but we want to say, hey sheep, run. We're the shepherd. We're the sheepdog. We're the whatever. All right. It's going to be part of making this a game. And so to do that, I'm going to go to the player, the actual player, not the main camera or anything, but the player. I wish I hadn't done that. There we go. There we go. Go away. And on the player, I'm going to go ahead and add a component. I'm going to add to it physics and a sphere collider. And on the sphere collider, I'm just going to give it some radius. And I always kind of choose something different every time, but I don't know, 2.7 to 183, whatever. Just your width around you that you scare sheep. Maybe 2.5. Also, I want to make this a trigger. I don't want to actually physically push the sheep. I just want to trigger the sheep to run. Now, you'll recall that we're going to be a little bit above the ground. We have a virtual body. As such, I don't want the center of the sphere to be around my head. I just kind of want to drop it down a little bit to be around maybe where my feet were, or middle of my body, just somewhere below. I know my height is 2.5 by default, so I just dropped it down a bit. If you don't do that, this will still work. This is just going to increase our radius, so it's just an optional thing. So now that I have this trigger sphere collider, I'm also going to add a rigid body. Oops. Add component, physics, rigid body. Now I don't want actual physics applied, so I'm going to check is kinematic. All right, and with is kinematic, the physics won't be applied, but I'll still get my collisions and stuff like that. And so the last thing I kind of want to do here is, so I have my collider, and I can prove that by just turning the trigger part off and then seeing how crazy it behaves. Pushing sheep around. Oh, it's not even going to do that. They don't even register. But besides that, oh, that's right, because I made it. Yeah, kinematic. But besides that, I'm going to go ahead and add a script that's going to tell the sheep to run away. So I'm going to go to my scripts folder. I'm going to grab the shepherd script, and I'll just drop it on my player as well. And the shepherd script is, again, very simple. It's not commented yet, but it will be. First off, we just say, hey, when we scare a sheep, how far do they run? And so we'll say 15 meters or 15 units. And how high off the ground are we? And this will automatically be filled for us. It's not even public. Inside start, we're just going to get this player mover script, and we're going to ask it, okay, how high are we? And record that. And then we have on trigger stay. I might change this to on trigger enter, but it doesn't really matter. On trigger enter, on trigger stay. The reason I did on trigger stay is because we're teleporting and it may miss the collision initially. So I just did on trigger stay instead. But I think either would work. And so inside, when the sheep hits our collider, we're going to attempt to get a sheep component off of it. If we don't get a sheep component, it means it's not a sheep and we don't have to do anything with it. And then I'm going to go ahead and say vector 3 ground level. All right, so I don't want to calculate the distance between the sheep and myself from my head, which is floating up in the ground or up in the air, to the sheep's feet on the ground. Instead, I want to calculate from my feet to their feet. That way we get a straight line as opposed to a downward arrow. And so I'm just going to say, okay, ground level is my current position minus my height. So take the y and subtract the height. And that's going to find the position at my feet. And then I'm going to go ahead and say, okay, give me my movement vector, which is my ground level, which is my feet, minus the feet of the sheep. That's going to give me my vector. And then I'm just going to multiply that by my scare distance. And I'm going to tell the sheep, hey, I'm scaring you, and that's by how much. And the sheep will run away. Again, this will be commented. Also, I am going to make this on trigger enter. It should work just fine. And that way this code isn't running every single frame, which is really inefficient. So there we go. We like efficiencies. And so now I'm going to go ahead and hit play. And when I teleport down next to a sheep, it's going to go running and getting sucked up into the sheep-o-matic, which is just a natural part of this project. All right. And if people are curious how it works, the scripts are inside the demo files, but it's really not relevant for the rest of this sort of workshop there. So for this cycle, step 6, what we're going to do is we add a trigger sphere collider to the player, we add a kinematic rigid body to the player, and then we add the shepherd script to the player. All right. Next, we're going to add some UI, and there's a couple of things we can do for UI. This isn't actually part of this version of the project, but you could do it anyway. Is if I go to my prefabs folder, I have this nameplate prefab, which is a world canvas with a look at script on it. And if I wanted to, I could say just take this prefab and drop it on Elvis the sheep. And what it's going to do is just going to put a name over the sheep, which I could say, something like Elvis. And then on that nameplate, it's also going to say, okay, I want to look at the player. What's the player? And I could just click and drag the player and drop it on there. By doing that, the nameplate always faces me. So I can always just see the name of the sheep right above its head. There we go. So that's actually not even a part of this step, but I just wanted to show you that the nameplate is in there in case you want to use it to give the sheep some names and to also show off World UI a little bit more. So now what I am going to do is I'm going to go to create, I'm going to go to UI, canvas, and this is going to add another canvas in my scene here, which I'm going to add to it a text object. Now on this canvas, I'm going to make it a world space canvas, and I don't need a graphic raycaster, so I'll just go ahead and remove that. I'm going to talk about these pixels per unit shortly, but I am going to drop my reference pixels per unit down to 1. Now, the width and the height and the position, all that stuff, I'm going to make my width and height 10. The width and height of this box will not matter. I could do 1,000, I could do 0.1, I could do 10, whatever. 10 just makes it a nice manageable rectangle for me. And I'm going to put it at 0, 0, 0, which now if I look is, just right there. And it's got this giant text on it. So we'll see how blurry this text is here. And the reason for that is this other one, this dynamic pixels per units. And that's the pixels per units for dynamic stuff for UI, and text is dynamic. So I kind of just want to increase this until it gets better. And you can see here as I slowly increase it, it slowly gets better. I find that it caps out at high quality around 11 dynamic pixels per units. Any more than that, and it starts to maybe over sharpen. So you can see how if I change it to like 18, it gets grainy a little bit. So 11 seems to work really well. So now that that canvas is set up there, I'm going to go to my text. And on the text, all I'm going to do is I'm just going to go ahead and align it and maybe make it bright red and make it say game over. And then I just need to position this. So what I'd like to do is I would like to take this canvas here and just sort of hide my text in the ground. Now I can see it's kind of spilling over the ends there, so I'm going to change my font size to maybe 12 point. And this is just kind of one of those eyeballing it things. I could be more specific or precise, but honestly this will do just fine. There we go. And so when my text pops out, it'll pop out like right there. Okay. And so now what I'm going to do is I'm going to add a script to this canvas. And this script that I add to the canvas is going to be responsible for keeping track of my score. So I'll go to scripts and I'm going to find this thing called scoreboard, which I'm just going to drop right on the canvas. And scoreboard is very basic. It is just saying, okay, how high should it move once we tell it to. Some smoothing because it's going to lerp. How many sheep are in our scene? This is a singleton, which means it's going to have a public static reference to itself. The reason I did this is because the Shiro-matic, which I don't want players to get into because it's a lot of more complex code that no one should care about for this. And all I wanted to do is be able to say quickly and easily, hey, if there is a scoreboard, tell it we captured a sheep. And that way the players don't have to, or the viewers don't have to go into all that stuff. So inside the scoreboard here, besides the fact that it is a singleton, it is going to say, okay, we have a function called sheep captured. And if the game is already over, then just leave. Otherwise, subtract the number of sheep. Now, if there are still there are still sheep left, then leave. We don't care about it anymore. But if we're out of sheep, if there are no more sheep left, then hey, guess what? Game over is true. And we record where we want our scoreboard to move to, and we start a coroutine to lift it up. And until we reach our destination, so the distance between the 2 points is greater than 0.1, we're going to go ahead and just lerp it to that position. And so I'm going to go ahead on that scoreboard and just say, hey, I want this to move up like 30 units. Smoothing of 5 is fine. And then how many sheep? I could say 3 because that's how many there are. But instead I'm just going to say 1, so we'll see it work when I just score with a single sheep. And I'll hit play. And I'll drop down here and try to... There we go. Game over. Okay. And so we can see how that shows in kind of world space UI there. And we could build probably a more robust version of that, but with only an hour to the workshop and the fact that you need this in like a day, that's going to be pretty basic, pretty straightforward. Okay. And so for that step, the nameplate part, again, just to talk about it because it's not on the slides, is to simply go to prefabs, nameplate, drop it on a sheet, and just tell it, what the player is. So that one's pretty straightforward. But otherwise, You're going to create a canvas and a text game object in the scene. Change the canvas to world mode with a dynamic pixels per unit of 11. Change the text to say game over, and position the canvas and the text below the ground so that it can pop up. And then you can fill out the properties of the scoreboard script after you add the scoreboard script to the canvas. All right, so the last step here is one I'm not going to be able to demonstrate. I don't even really have text for it. It's build for VR. And at this point, for this PowerPoint slide, you can just sort of fill in for whatever platform you happen to be using. Gear VR, Oculus, or whatever. I mean, it works on pretty much anything. So this is where you'll fill in, for your particular audience. And so for me, I'm doing Gear VR. So at this point, you can see I'm already on Android. I would turn on VR supported or VR enabled, and I already have a plugins folder with my SIG file in there to test on my phone, right? So everyone's setup is going to be a little bit different, but you can just add your own notes there for people to follow along. And then we have the survey slide at the end. So that is, in a nutshell, the 1-hour workshop, simple VR game. Hopefully that meets your criteria. And if you have any questions or comments or anything, just go ahead and let me know. Thanks.